Hi learners, we have integrated science and this is lesson 6. Today, still under energy, we are looking at light energy. Light energy. In our previous lesson, we touched on conversion and conservation of energy. In this lesson, you are expected to define the term light energy by the end of the lesson, identify the types of sources of light energy, and be able to mention properties of light. So what is light energy? What is light energy? Light energy is defined as a form of energy that stimulates our sense of vision. It enables us to see, or is a form of energy that travels in a straight line and enables us to see. So that's how we define light energy. Now let's move on to sources of light energy. Now the sources of light energy can be classified into two groups. We have the natural and artificial or man-made sources. So what are natural sources of light? We are seeing they are sources of light created by God or nature. They are sources of light created by God or nature. The word nature is what scientists refer to. Now, let's look at examples of natural sources. Before I put down a list, I hope you can mention some of the natural sources of light. Yes, the ultimate one that comes to mind is the sun. Then we have the stars that we see at night. Firefly. And from here you can see the firefly. This is a firefly. Then we have glowworm. This is glowworm, a worm that produces light. Glowworm. And then we have some deep sea fish. They are also called bioluminescence fish. Bioluminescence fish. Now, before we move on, you have to understand that all the examples here are direct sources of light. They are direct sources of light. However, moon, even though a natural object, is not a direct source of light. Take note, moon is not a direct source of light. It behaves like the way the mirror behaves. As the mirror reflects light from a source onto a surface, so the moon also reflects light from the sun. That means without the sun, the moon would not produce light. So the moon is not the direct source of light. So never mention moon as an example of natural source of light. It will be marked down in any examination that you write moon as an example. Now let's move on to artificial or man-made sources of light. What are artificial or man-made sources of light? Of course, if natural is by God, then artificial will be by what? Man. So we are saying these are sources of light, these are sources created by what? Man. So now let's look at examples of artificial sources of light. Examples of artificial sources of light. The pictures are here. So let's list them. Of course, we have the candle lights. This is a candle light. Then we have the, what do you call it, lantern. This is a lantern. We have the lamp. This is a lamp. And of course, we have the matches. This is the matches. Okay. So now let's move on to properties of light energy. Properties of light energy. Properties of light energy. By properties, we mean the characteristics. What makes light energy different from other forms of energy? So 1, as we pointed out in the definition of light energy, it travels in a straight line. Take note, it travels in a straight line. It travels in a straight line. 2, it can be reflected. It can be reflected. That is, light can bounce off from a surface, can bounce off like how a ball bounces off from the ground or from the wall. Bounces off from a wall. Then we say that light can be refracted. Refracted, not reflected. Reflected is bouncing back. Refracted has to do with the change in direction of light as it travels from one medium, maybe air, into another medium, water. Because of difference in densities, the light appears to bend. So that's refraction. This explains why when a stick is partially put in water, or a pen partially put in water, you see it slightly bent. No, the stick is not actually bent. It is a light coming from the part of the stick in the water that bends as soon as it hits the surface of the water into your eyes. So you see the image as bent, but the pen itself is not bent. So that's a property of light. Refracted. It's not reflected. Reflected is bouncing back. This is refracted. Okay, let's move on to the fourth one. We're saying that light can be diffracted. Diffracted. What does it mean, diffracted? It means light can spread. Light can spread in all directions, can spread. If I should have this thing like torch producing light, you see the light spreading in all directions, covering larger area than the face of the torch light. The torch light might look small, but the area it is casting the light at may be very large. Why? Because light can be diffracted or can spread from a point. So take note of the term diffracted. Then, at a very enormous speed, light travels at 3.0 times 10 raised to the power 8 meters per second. What that means is light travels at a speed of 300 million. I repeat, 300 million meters per second. The board rule used in the classroom is 1 meter. So that 1 meter, 300 million times in 1 second is the speed of light. If you want to use kilometers, then it is 300,000 kilometers per second. Okay. Now let's move on to our summary. So what have we learned today? Today we learned the definition of light energy as a form of energy that enables us to see. We also touched on the types of sources of light. We mentioned natural and artificial sources of light. And we noted under natural sources of light that moon is not a natural source of light because it does not produce light on itself, just as the mirror is not a source of light. Then we move on to look at properties of light. We say light travels in a straight line. Light can be reflected. Light can be refracted. And light can be diffracted. And finally, light travels at a speed of 300 million meters per second or 300,000 kilometers per second. Alright. For our advanced learning, try and read on rectilinear propagation of light and study the diagram and the experiment under rectilinear propagation of light. This will be the focus of our discussion in our next lesson. Congratulations for your patience. Do your best to download the exercise, do it and upload it for me to access. Hopefully, by the close of this weekend, we will have the scores of this week's lessons or assignments. Till we meet again.